1.5 segments and angle bisectors. We're going to start off today with more definitions, more words to know. You need to know what midpoint is, and not just kind of what it is, but know the definition. Midpoint divides a segment into two congruent, okay, that's the symbol for congruent, two congruent parts. Okay, another word for divides is bisect. Okay, it's going to split it. A segment bisector is a segment, ray, line, or a plane that intersects a segment at its midpoint. So basically a geometric figure that intersects a segment at its midpoint. So in this case, this would be the segment bisector, okay, if this is the midpoint. Now, these red marks here are congruence marks. Okay, that's how we show that this segment here is congruent to this segment here. An angle bisector is a ray. So this could be, a ray line or whatever, but this has to be a ray that divides an angle into two congruent parts. So now if they're congruent, remember congruent means they have the same measure. So here we have these congruent arcs. Okay, so up here we had congruent tick marks. Here we have these congruent arcs, and we use those to show that the angles are the same. Let me see. Shows angles are the same. Okay, maybe we'll do something like that. Those congruent tick marks show segments are the same. Another formula, put it right next to the distance formula in the front under the front cover of your notebook, is the midpoint formula, and here it is. X1, X2, remember those are referring to X coordinate of your first point, X coordinate of your second point. So we're going to put one number in for this X sub 1. Okay, now how I remember this formula is it's the average of my X coordinates. Right? If I have two things, I add them together and divide by 2, it's the average. And that's what we're actually looking for. Okay, so if I want to find the midpoint of this segment, remember a midpoint divides it in half, so you could visually see where this segment would be divided in half, and that would be my midpoint. We like to use the letter M for midpoint. I don't have to, but it's a good one. If you notice, this length here is going to have to be the same as this length here, and you could show that with the Pythagorean theorem. Up 2 over 3, right triangle with side lengths 2 and 3, another right triangle with side lengths 2 and 3. This is my midpoint. Now, to find it, if this is 2, right, over 2, and my other x coordinate is 6, 8, I could find the average of 2 and 8. 2 plus 8 divided by 2 is 5. 1, 2, 3, 4, 5. My midpoint needs to be when x is 5. Okay? Remember, this coordinate is actually 8, and the y part is 7. And this coordinate here is x is 2, y is 3. So 8, 7 was one point, and 2, 3 was my other point. And I said my midpoint had to be halfway between, and we said that was 5. And, oh, we didn't figure that one out yet, but you could see it's going to be 5, 5. Okay, halfway between 3 and 7, right? Halfway between 3 and 7 is 5. So coordinates of my midpoint are 5, 5. Now we like to put the letter in front of it. That's just referring to point M, is that the coordinates x is 5, y is 5. One thing that I like to show at this point, remember it's the average, it's splitting it into two equal parts, right? So what is the difference here? Is there a pattern? From 7 to 5 to 3, you're going down 2. From 8 to 5 to 2, you're going down 3, right? Down 2, I gotta go down another 2. Down 3, gotta go down another 3. And I actually like to use this for the next part. It's a lot easier than the using the midpoint formula. So find the midpoint of DE with the given endpoints. Well, here we're given endpoints B and E. So 3, 5, and -4, 0. I want to find halfway between those. So halfway between 5 and 0, that one's easy. You can use the midpoint formula. 5 plus 0 divided by 2 is 2.5. That's halfway between. Down 2.5, down another 2.5. From 3 to -4, that's where it gets a little bit more tricky. 3 to -4, that's where you might want to use your formula. I get -1 over 2, which is a -0.5. And you could leave them as fractions as you want. So I went down to 3.5, and then down another 3.5. And now the midpoint is given to us. We know what M is. Our midpoint's 3, -4. And we know one endpoint Y is at -3, -1. How can I find my other endpoint X? So this is where I'm going to use that. I went down another 3 from -1 to -4. So in order for -4 to be the midpoint, I have to go down another 3 to -7. Here I went from -3 up 3. I went up 6. So I'm going to have to go up another 6 to 9. And you can check your answer by 9 plus -3 divided by 2. Add my two endpoints divided by 2. 9 plus -3 is 6. 6 divided by 2 is 3. That point's right. You could do the same theory to double check to make sure you did it right. You could use definition of midpoint, x1 plus my other x coordinate, which was -3, and you could actually solve that for my midpoint. My x coordinate was 3. I could solve this, but it's just a lot more algebra. Alright, here ray JK bisects angle HJL. So I'm going to draw angle HJL, and I know I have a ray JK bisecting it. So I'm just drawing a picture to help me with the problem. I'm given that angle HJL, this big angle, right here from here down to there. That angle is 42 degrees. So notice when I make this bigger angle, I'm talking about from here to here. If I wanted to talk about the smaller angle, I would have needed this line in here. Okay, this line is saying the big angle is 42 degrees. And we had this ray bisecting it. It's important to know what bisects mean. What are the measures of angle HJK and angle KJL? So the measure of angle HJK, if it's bisected, it means it split it in half. So measured angle HJK, this angle has to be half of the total. Half of 42 is 21 degrees. And the measure of KJL, remember it's bisected, so it's two congruent parts. They have the same measure. So measure of KJL has to be the same. It's equal to 21 degrees. Skip that one. So on a test and in your homework, you'll have to do problems like this. You're given that MO bisects angle LMN. If it bisects it, what does that mean? That the two parts are congruent, right? If they're congruent, they have the same measure. So they're the same, right? So whenever you see bisects, you better be thinking we have some things that are the same, right? Same means equals. So I need to write an equation to help me out. So I'm going to say 3x minus 20, because I'm trying to solve for x, so I need to write an equation to solve for x. And I know that they're equal to x plus 10. Now, sometimes they're the same and they're equal, and sometimes we're going to have things that are supplementary, which means they add to 180. We'll get to that tomorrow here. But as of right now, I have variables on both sides of the equation, so I want to get them to one side of the equation. So I subtract x. I'm left with 2x minus 20 equals 10. Now I want to get x by itself, so I have to undo the order of operations. I'm going to add 20, and I have 2x equals 30. Divide by 2, x equals 15. And now sometimes they might ask, what's the measure of this angle? You just put 15 back in for x, and you'd say 15 plus 10. This must have been a 25-degree angle. Here's your homework for tomorrow in class. That's what we're going to be working on in class. So you can write that down into your notes and have a good evening.